Okay, so the next topic after work follows directly on the heels of that and is, the next stepping stone up, and this is power. All right, power is directly related to work. In fact, power very much involves working. So, in the physics sense. So the question for power is how fast can you do the work? All right, power is all about speed and how much work you do. But it's mostly about how fast you do the work. All right, so here's a question. That guy, that's capable of doing some work. It's a car. It can carry things places. Can apply some force over distance, and that'll do some work. Especially if we're going uphill, for example, carrying the weight of all passengers. This guy can do work, right? He can do some work. Might take him a little while, though. He's a little beat up, kind of old. Let's compare that to this guy. All right, yeah, that's what I'm talking about. That is a cool car. In fact, this is a Lamborghini. All right, so maybe you don't know much about cars, but I think you might know enough to be aware that, this guy can go a lot faster than this guy. All right, so essentially, if these two cars, right, this car and this car, if we are putting them to the task of doing the same amount of work, all right, so they're lifting the same load, they have the same weight, whatever, they're moving some things the same distance, all right, same amount of work. Which one of these can do it faster, I wonder? Yeah, that's not even a question, right? Clearly, this guy is going to be much faster at doing the work. So that guy has more power. That's a reference to an old TV show called Home Improvement. But if you've seen it, then you'll appreciate that. If not, don't worry about it. So since this guy's faster, this guy has more power. More power. Okay. All right. Cool. So basically, the formal definition is that power is a measure of the rate of doing work, how fast you do work. So let's ask the same question we asked about work. We said, how can I do more work? Well, in this case, let's say, how can I be more powerful? Well, you have two options again. You can do more work in the same amount of time, or you can do the same amount of work faster. All right? So basically, more work or work faster. Okay? Those are the two ways that you can be more powerful. All right? So let's take an example. Poor Bob here, is lifting boxes again. I use that example because it seems to show up fairly often. Lifting things up on a conveyor belt or using a conveyor belt to lift things up onto something like bales of hay or boxes or whatever. They like to use that kind of example in IG physics exams. So that's the example I chose to use in explaining this, but it doesn't have to be boxes being lifted. All right, any kind of work being done over a period of time counts. Okay, so this guy is lifting boxes. All right, so his name's Bob. He lifts a 100 Newton box from the floor to a 1 meter height on a table in 5 seconds. How much power did he develop? Now, we talk about developing power. It's just a vocabulary thing, right? So, how much power did he develop? Well, let's go back here for a second. All right, back up. All right, we said power is related to work and time. So we need to go ahead and give our equation here. All right, so power is equal to work done divided by time taken. So how long it took. All right, so work over time is our equation for power. All right, cool. So if we apply that equation to this situation, his power is going to be equal to the work done, which we're going to have to calculate that, 100 newtons times 1 meter of distance, So 100 newtons times 1 meter. And then we're going to divide by 5 seconds. All right. So this part on the top here is just the work done because it's force times distance. So that's just going to be 100 joules. And then you divide by 5 seconds. All right. And you can see really immediately that's just going to be 20. So that's going to equal 20. What is it? Joules per second, right? Joules per second. Or there's a special unit for that. Okay? Special unit. The unit for power is watts. Named after a guy named Isaac Watt, who was very involved with the initial work with power. All right, so a unit of power is watts. So we could write this as 20 watts with a W, capital W is how we abbreviate that. Okay, cool. I love this stuff. Alrighty, one last example. We're going to compare things. All right, who has more power? All right, so we have a story problem here. Bob's body has a mass of 80 kilograms. Sally's body has a mass of 50 kilograms. They're going to race to the top of a hill, and the peak of the hill is 100 meters higher than the base of the hill. So they're covering a vertical distance of 100 meters, and they're working against their body weight. All right, so basically the force they're applying is equal to the weight of their body. And then the distance they're applying that force is 100 meters. All right, so they're racing. Sally beats Bob, and she completes the run in 30 seconds. All right, say Bob completes it in 40 seconds. So Sally won the race, but the question is, who was more powerful? Who developed more power? More power! All right, let's see. Okay, so we're going to calculate this out. Go through the steps really quick, and then I'll do it off to the side here. So the first step is to convert kilograms into newtons. Because kilograms is a measure of mass, we need the measure of weight, which is a force. All right, after we do that, we will calculate the work that is done by each of them against the force of gravity. All right. Third, we'll calculate the power that they each develop, and then we'll just compare the two different power. All right. So Bob, we'll label Bob here, Bob. And then we'll have Sally next to Bob for the calculation. Okay, so here's Sally. So Bob has 80 kilograms of mass. So he's going to have 800 newtons of body weight. All right, let me just make that 8. Right, that's awful handwriting, but you get the idea. All right, just cleaned up that writing a little bit. Okay, so Sally then has a body mass of 50 kilograms. And so she's going to be 500 newtons of weight. All right, both of them are going vertically a distance of 100 meters. So we're going to multiply this number by 100. All right, and then I'll write that below in red. All right, so if you do that in your calculator, you're going to get 80,000 joules. Whoops, I missed a 0. Joules for Bob, and you're going to get 50,000 joules of work done by Sally. Now, here's the question. Bob took 40 seconds to do this, so we're going to figure out how many watts he developed. All right, so we'll use our calculator for that. And before I write this down, I should point out this is not very realistic. This example is like Bob and Sally are kind of super powered people. Most people can't develop this much power, but you know, whatever. We'll just go with it. It's just an example after all. So if you divide this by 40 seconds, so I'll just go ahead and write that. Divide by 40 seconds, you're going to get 2,000 watts. All right, that's the power developed by Bob. All right, so Bob has 2,000 watts of power. Let's check for Sally. Sally did that in 30 seconds. So if we put that in our calculator, divide by 30 seconds, put it in your calculator, and then I'm going to round it off to two significant figures, which is rounding up. So we're going to say 1,700 watts is what Sally developed. So there you go. We calculated the power for each of these individuals. Bob developed 2,000 watts. Sally developed, if we round it off, 1,700 watts. So who's more powerful? Bob is more powerful. Even though he lost the race, right? He can still brag that he's more powerful than Sally, at least. All right? Cool! So that's the basic idea of power.